Hello, I hope everyone's doing fine. I have already recorded a video on the DMA review for quiz one where I took the past FE questions. Now I'm going to record a video going over some of the popular recursive questions that I have compiled. Uh, these questions, plus the questions that we went over in the lab, plus the questions that are posted in the recursion module in web courses, should give you a very solid understanding of how to approach these questions and how to solve them using recursion, right? Another thing that I did when I took this class is I tried to draw a recursion tree for each and every single question that I solved. This way you can it becomes very easy for us to like visualize the problem and solve it. So with that being said, I'm just gonna jump right into the video. And the very first question that I had is reversing a string. So the question one, sorry. So the question one I'm going to cover is reverse a string or a integer array or int array. The same logic applies here, like the method that we're gonna use is applies for both of these. So let's just try to reverse a string. So first of all, let me explain how to like reverse a string, right? So let's say we have a string. Let's just call it A, B, C, D. So the method for us to reverse a string is we're going to use a very popular approach. It's called the two tracker approach. So we will have a tracker here. Let's just call it low or left. And we will have a tracker at the very rightmost position. Let's call it right. L for left and right for right. And R for right, sorry. And what we're going to do is at each iteration, we're going to swap these positions. I mean, swap the element at these positions. So what it will look like, it would be at the very, so this is like the initial, and at the very first iteration, it will look like, after swapping, it will look like D would be here, B would be here, C would be here, and then A would be here. Now I'm gonna increment my left pointer or left tracker and my right tracker. Again, I'm gonna do the same thing. I'm gonna swap these elements. So at the second iteration, let's do a couple of dry runs. So it will look like D would be here, C would be here because I'm gonna swap these two values, and then B would be here, and then A would be here. So now if you see, I have essentially I have like reversed the string, right? So the string was A, B, C, D. Now I have reversed the string, and it is written as D, C, B, A. So that's like the popular technique of reversing, and you can apply the same logic for an integer array, or and that's how you effectively reverse a string, right? So let's start the function first. So it'd be void reverse. It will take a character string. Let's say it's a dynamic string, and let's call it str. Then we have an integer that would be a left tracker, an integer that would be a right tracker. What we would do is we write the base case. So the base case would be at any point my left tracker is equals to my right tracker, meaning they're at the very same position, right? So that would only occur if the length of the string was an odd number, uh, or let's just say at any point my left tracker is bigger than or equal to my right tracker, I want to stop, right? And that's because if they're at the same position, then I know for a fact that I don't need to reverse it, right? I'll show you an example of this with an odd string. So, but for now, let's just let this be our base case, right? So if my left tracker is at any point bigger than my right tracker, I want to like stop, right? So I'm just gonna say return, because that means I have effectively already reversed the string, so I don't need to do any more steps, right? Now what I'm gonna do, I'm gonna just write a very simple code to swap two integers or two characters, right? So I will have a character, let's call it temp, that would take str at the left position. So it would take the value of the string at the left position. Then what we'll do is string at the left position catches the same value as string at the right position, right? Once we have done that, I can just say string at the right position catches the same value as, and then I'm gonna make a recursive call to the function and keep doing it again and again until my left tracker has is at the same position as the right tracker or it has crossed it. So I'm just gonna say return reverse, call it my string left plus 1, and then right is decremented by 1. Okay, now let me show you an example with a odd string. So the even string, that makes sense, right? So my left, we will begin my left tracker from here, right tracker from here, swap these two swap. Then we would go on to my second iteration. My left tracker would be here, my right tracker would be here, swap, and then the base case would take in place, right? Because my right tracker would be here and my left tracker would be here, and my left tracker is at the position 0, 1, 2, 3. So my left tracker is position 0, my right tracker is at position 1, and that the base case is met, right? Left is now 2 and the right is now 1, so we return. Now let me show you how to do let me do a dry run with a string that is of length this is of an even length, right? So let's do this. You have 1, 2, 3, 1, 2, 3, 4. So let's say we have A, B, C, D, E. Okay, that is our initial point, right? First iteration. So I'm just gonna let's just call it the very first iteration actually. So initially it would be like this, but let's just do it. So my left tracker is here, right tracker is here, swap these two values, right? So it would become E, B, C, D, A, right? In my second iteration, it would be E, B, C, D, A. My left tracker is incremented by 1, my right tracker is decremented by 1. Again, I want to swap these values. So after my second iteration, my string should look like E, D, C, B, A. In my third iteration, it will look something like E, D, C, B, A. And then my left tracker would be at this position, my right tracker is at this position. Now I'm at the middle position and my left tracker is the same as my right tracker. So I don't need to swap these two values, right? Because they're at the same position. The C, which is in the middle, it doesn't really matter if I swap it with itself, because even if I flip the string, even if I were to like flip the string, the C would still stay in the middle, right? So it would be like A, B, C, D, E. No matter if I were, okay, now let me just reverse this thing, right? So it would be E, D, C, B, A. As you can see, the position in the middle stays intact. So it doesn't really make sense for me to like swap, right? Because left and right, they're effectively at the same position. It doesn't really make sense for me to swap. So that's one of our, that's exactly why our base case says if my left tracker is bigger than or equal to my right tracker, stop. So hopefully that makes sense. Pretty simple question, pretty straightforward. Try to do it, try doing this yourself, but instead try reversing a integer string. Same thing follows here. And also one more thing that I wanted to go over. I'm not, as you can see, this is a void function because the string that is being passed. So in C, the strings, they are passed by reference. So I'm effectively changing the string itself. I'm not changing the like copy of the string, right? So I'm going to that address and then I'm making all these changes because a string, I mean, sorry, not strings, arrays are passed by reference. So I'm going to that address, making the changing, and then you know, ending my function. So hopefully that makes sense. Pretty straightforward. Okay, now let's try solving the second question. Let me explain what the question is asking us. The question is essentially telling us that, hey, a function will take a n integer as a function parameter, And what we have to do is we have to sum up the whole n and then return the sum of the digit, right? So for example, n that was passed to the function was 987. We would need to do 9 plus 8 plus 7, which would give us the value of 24. uh 24, and then we would have to return this to the function itself, right? So let's write the function int sum digits, and it would take integer n as the function parameter. So it would make sense like the base case. Think of the base case. If my base case should be if n is already 0, I don't want to do anything, right? So if n is already 0, I can just return 0, right? Because the sum of 0 is just 0. So that's the base case. And then what we would do is we would return n mod 10 plus the function call sum digits n divided by 10. Now, so let me explain what is going on. Let's say we passed on the function 987, right? When we do mod 10, it would give us the very last digit, right? Because the mod returns the remainder, right? So it would give us, when we do 987 modulus 10, it would give us 7, right? And then here, when we do 987 divided by 10, it would give us 98, right? We are doing integer division, so what it does, it would it floors the value, right? So let me try drawing the recursive tree for this so you can better understand like what's going on. And this is like just the formula, just to remember like how to get the very last digit of a number. Like you can just mod it by 10 and it will give you the very last digit of the number. And if you want to get rid of the very last digit of the number, you can just divide it by 10. So just remember that. Let me try drawing the recursive tree. So let's say 987 was passed to the function, right? The very first call, it would be 7 because modulus 10 plus the function call of 98, right? Then from this, it would make another call. Here, it would be 8 plus the function call of 9, right? Again, I will mod 10. It would be 9 plus the function call of 0, right? Or sorry, 1. Should be 0, no? Yeah, because 9 divided by 10 should be 0. 9 divided by 10. We get the answer 0.9, so it would make it would just like go to the very it would float the value, and then it would make the call with f of function of 0, and this is effectively our base case. So in our base case, it would return 0 to the last caller, and it would do 9 plus 0, and then it would be 9. 9 would get returned to the last function call. It would do 9 plus 8. It would do 17, and then 17 would get returned to here, and it would do 17 plus 7, which is 24, and we get an answer. So hopefully that you were able to understand this. Try doing this. Try drawing this recursive tree with a couple of your own examples, so it like makes sense, like how we like came up with the answer, right? So now let's go to the third question, which is, given an array, you need to check if the array is in sorted order or not. Okay, this question is pretty interesting. So let's write the. I don't think I need to explain this question. It's pretty straightforward. Given an integer array, just check if the array is sorted, and then we're assuming that the sorted here means that the array is in ascending order, right? Not descending order, but ascending order. So let's just write it is sorted. It would take an integer array again, and it would take int n, which represents the length of this array, right? So the base case would be if my n is 0 or n is equals to 1, I want to stop, right? Because let's say the length of the array is 0, meaning it is completely empty, right? It doesn't really make sense for me to check if it is sorted or not because it's empty. And this, or it says if n is equals to 1. If the length of the array is 1, meaning it only has one element, then also it doesn't really make sense for me to check if it's sorted because there's only one element. So it's already in position, right? So I'm just gonna say return 1, meaning 1 meaning, hey, this is true. Uh, and then the base case would be, we're gonna start from the very back. The another base case would be if array at n minus 1, sorry, if array at n minus 2 is bigger than my array at n minus 1, I want to return false, right? I want to return 0. And if this is not the case, I want to make the recursive call return is sorted. I want to give in my array, and then I want to do n minus 1. Let me try like showing you an example. Like let me do it right on. So let's say we have an array. Let's do 1, 3, 5, 7, right? And then so it's 0, 1, 2, 3, and then n is my n, the which is the length of the array is 4. So we're pretty much like working from the back, and then we're checking if the array at n minus 2 is bigger than array at n minus 1. So this is not the case, right? I'm gonna go back and I'm gonna call the function with this position, right? This again is like n minus 2 and then n minus 1. This is not the case. I'm gonna go back and then call the function with n as so it would go n starts from 4, goes to 3, goes to 2, then goes to 1, and at that, this is the base case. We return 1 because uh, at no point there was a position where the position behind it was bigger than itself, right? So hopefully that makes sense. If not, I can always explain this more in depth in my office hours, like what questions you had. Since it's a recording, I don't really have a chance to for you guys to like ask me questions. But if you come to my office hours, I'll be more than happy to explain it more in depth. So I'm just gonna draw it again. 1, 3, 5, 7. N is 4. We say so 0, 1, 2, 3, right? N is 4. We call the function and we check if n minus 2, which is position 2, so 4 minus 2 is position this, and then n minus 1 is position 3. We check if this position is greater than this one. It is not. Then we decrement n to 3. Then we check n minus 1. If n minus 2 is bigger than n minus 3, so 3 minus 2, which is position this, and then 3 minus 1 is this position this again here. 3 is not indeed bigger, so we just keep going backwards, backwards, backwards till n is equals to 1 or 0, right? Okay, so that's the third question. The fourth question is, given an integer array and n as its length, return the sum of all the elements in this array. So I'm gonna give you a couple of so this question is pretty similar to the question that we just solved. We kind of have to like work backwards because n is at the very length, right? So think of this. I'm gonna think of this like, so let's write the function words. Int sum elements. It would take an integer array. It would take int n as its length. Again, I'm gonna say if n is equals to 0, return 0, right? Because if my n is already 0, that means that there's nothing for me to find anymore inside the array, right? I've effectively gone throughout the whole array. Either that's the case or the array is just empty. So, and then I would just make a recursive call, return array at n minus 1 plus the function call sum elements array and then n minus 1. Let me draw a recursive tree for this. So let's say we have an array 1, 5, 7, right? So what I will do is the first recursive call, it would do array at position n minus 1. Let's say so n would be 0 1 2, so n would be 3 here, right? That's the total length of this array. Indexes are 0 1 and 2. So it would say array at n minus 1, which is array at position 2. So we'll do 7 plus the recursive call of n minus 1. So now n will become 2, right? It will pass in the array, and now it will pass in 2. Again, it would make the function call, and it would do, since n is 2 now, it would do n minus 1 again, and which will land at the position this. So we do 5 plus array, function call of array, and then we'll pass in 1 again, right? Then again, we will make the function call. N is now 1. It would do 1 minus 1, which will land at the position 0. It would do 1 plus the function call of array and 0. Since now this is the base case, we cancel this out, and then 0 gets returned. So it would do 1 plus 0, which is 1. 1 gets returned here. It does 1 plus 5. Then it would do 6. And then 6 gets returned here. And it would do 6 plus 7, which is 13. So hopefully that makes sense. Try drawing the recursive recursion tree for this on your own. The question 5, I'm not gonna solve it. I'm just gonna give you guys this as a practice. This is pretty similar to the question that we solved, which is like sum of digits, but instead of summing the digits, we're counting the digits, right? So int count integer n. So think of the base case, right? Base case goes here, right? And then we're also assuming that n is always a positive integer. If it was not a positive integer, we can just write a very simple statement saying like if n is smaller than 0, n equals to minus n, or we can just say n equals to absolute value of n, and then we can solve it. And then instead of summing, we're counting how many digits a number has, right? So for 987, it would be 3, right? So try thinking of, it's very similar to question number 2 here. But instead of getting the very last digit, you're just checking how many digits you have. So it would make sense to just replace it with a 1, right? And then at each and every time when you call this, so for example, we just return 1 plus the function call of n divided by 10, right? So what it would do is, let's say the number was, let's say the number that was passed was 789. So it would do 1 plus the function call of 78. Then it would do 1 plus the function call of 7. Then it would do 1 plus the function call of 0. And then it would backtrack. It would like go back, and then it would do 1 plus 1, which is 2. And it would do 1 plus 2, which is 3, which is the answer. Again, try drawing the recursion tree for this on your own. And if you do have any questions, you can leave a comment, or you can always visit my office hours, and I would be more than happy to help you. All right.